Good morning, sir. This is Ashwita from Computer Science and Engineering Department. I am here to give a presentation on principle and applications of NMR spectroscopy. Outline of my presentation. Introduction to NMR spectroscopy, principle of NMR spectroscopy, NMR instrumentation, chemical shift and spin-spin coupling, NMR spectra interpretation, advantages of NMR spectroscopy, applications of NMR organic chemicals, applications of NMR in biological sciences, qualitative analysis, and drug discovery. Conclusion. Let's move to next slide. Introduction to NMR spectroscopy. NMR stands for Nuclear Magnetic Resonance Spectroscopy. NMR spectroscopy is a powerful analytical technique used to study the properties of atomic nuclei. It is based on the principle of nuclear magnetic resonance, wherein nuclei in a magnetic field absorb and emit electromagnetic radiation. NMR spectroscopy provides valuable information about the structure, dynamics, and chemical environment of molecules. This is the picture of NMR spectroscopy. Principle of NMR spectroscopy. NMR spectroscopy relies on the phenomena of nuclear magnetic resonance, which occurs when atomic nuclei with an odd number of protons and or neutrons possesses a net magnetic moment. When placed in a strong magnetic field, these nuclei align with the magnetic field and can absorb and emit electromagnetic radiation at a specific frequency. The frequency of absorption or emission is influenced by factors such as the local chemical environment and molecular structure. This is the picture of NMR spectroscopy instrumentation. NMR instrumentation. NMR spectrometers consist of a strong magnet, a radio frequency RF transmitter, a sample holder, and a detector. The strong magnet creates a uniform magnetic field that aligns the nuclear spins. The RF transmitter generates a pulse of radio frequency radiation to excite the nuclei, and the detector measures the emitted radiation. Here, RF is nothing but radio frequency. Chemical shift and spin-spin coupling. Chemical shift is a fundamental concept in NMR spectroscopy and refers to the shift in resonance frequency of a nucleus compared to a reference compound. Spin-spin coupling occurs when two or more neighboring nuclei influence each other's resonance frequencies. NMR spectra interpretation. NMR spectra are typically represented as a plot of signal intensity on y-axis versus chemical shift on x-axis. The number of peaks in the spectrum corresponds to the number of chemically distinct nuclei in the molecule. The integration of peaks provides information about the relative number of nuclei in each chemical environment. Advantages of NMR spectroscopy. NMR spectroscopy is non-destructive and requires minimal sample preparation. It can provide detailed information about molecular structure, dynamics, and interactions. NMR spectroscopy is versatile and can be applied to a wide range of compounds from small organic molecules to large biomolecules. Applications of NMR spectroscopy in organic chemistry. NMR spectroscopy is extensively used in organic chemistry for structure determination and elucidation. It can identify functional groups, confirm the presence of specific atoms, and determine stereochemistry. NMR spectroscopy is also used for quantification, reaction monitoring, and studying dynamic processes in organic molecules. Applications of NMR spectroscopy in biological sciences. In biological sciences, NMR spectroscopy is used for studying the structure and function of biomolecules. It can provide insights into protein folding, ligand receptor interactions, and enzyme kinetics. NMR spectroscopy is also employed in metabolics and drug discovery to analyze complex mixtures and determining binding affinities. Applications of NMR in quantitative analysis. NMR spectroscopy can be used for quantitative analysis of compounds in various matrices. It allows for the determination of concentrations, purity, and reaction kinetics. NMR-based quantitative analysis is particularly useful in industries such as moleculates and food science. Applications of NMR in drug discovery. NMR spectroscopy plays a crucial role in drug discovery and development. It helps in the identification and optimization of lead compounds. NMR based techniques such as ligand based screening and fragment based drug design aid in the development of new drugs. Conclusion. NMR spectroscopy is a versatile technique with numerous applications in various scientific fields. It provides valuable insights into molecular structure, dynamics, and chemical properties. The continued advancements in NMR instrumentation and techniques make it an indispensable tool for researchers and scientists. Thank you. This is presented by Ashwita from Computer Science and Engineering Department.